Okay, welcome back to another video on the Math channel. It's your teacher, Mr. Lim here, and in this video, we are going to be looking at odd and even functions. But before we do that, I want you to have a go with these recap questions. So I want you to pause the video, have a go with these questions, find a domain and range in interval notation for the following graphs, write the equation that reflects y equals minus 2 to the x across the y-axis, and write the equation that rotates y is equal to root x 180 degrees about the origin. Okay, so for question 1, it's best for us to determine what kind of shape this is. Well, because it's x squared, it's going to be a parabola. But because it's going to be minus x squared, it's going to be concave down. So all we need to know is what is the turning point? Well, the turning point, we know the vertex is going to be minus 2, minus 5. Okay, so opposite sign, so it's going left to minus 2 and down 5. So the turning point will be at minus 2, minus 5, and it's going to be concave down. Okay, which means that it's going to be all real x, or the domain is from negative infinity to infinity. And the range, because we know that the y value is less than or equal to negative 5. So maybe we can write it like this: y is less than or equal to negative 5. That should help us know that we are going from negative infinity all the way up to minus 5 inclusive, because we include minus 5. Okay, because we include minus 5 here, we use the square bracket. Okay, so I'm just going to get rid of that, and we're going to move, I'm going to move this across. Okay, question B. We have x squared plus y minus 7 all squared is equal to 4. What shape is this? This is a circle, and the center of the circle is going to be 0, positive 7. So here there's no brackets, right, for x, so it's not moving left or right, so it's just 0. But this minus 7 tells us it's actually going to go up 7 because it's in brackets. The brackets tell us we move in the opposite direction. So center is 0, 7, and the radius is 2. Okay, the square root of 4 is 2. So when we draw this, 0, 7 is here, and we have a radius of 2. We'll just call that 5. And 9. I know it's not to scale. That's okay, but it's going to look something like that. So the domain, or the x values, is from minus 2 to 2. Oh, sorry, we don't use curved brackets because it includes the minus 2. We use square brackets. And because it includes this 2 here, we use square brackets. Range is from 5 to 9. And we use square brackets for both because it includes the 5 and the 9. Okay, in part C we have y equals 1 on x minus 6 plus 8. We know that this is a hyperbola, which is moving to the right 6 and up 8, which means that we will have asymptotes at 6 and at 8. So it's going to look something like this. Okay, and we know it's going to look something like that because here it's positive 1. It's not negative. There's no negative out here. Okay, or in front of it. So it's positive, so it's going to be shaped like this. If it was negative, then it would be shaped this way. Okay, and so therefore, we can see here that the domain, we can have a look at the left arm, is from negative infinity all the way up to 6, but we don't include the 6. Okay, because it'll never touch the 6. Or the right arm, okay, so we need to use the union from 6 all the way to infinity. The range, however, we'll have a look at the left one, is from negative infinity all the way up to 8. But it never touches the 8, so we don't include it. That's why we use the curved bracket. Union, or the right arm, from 8 till infinity. Okay, but we don't include the 8. That's why it's curved. Okay. We're going to write the equation that reflects y equals minus 2 to the x across the y-axis. So whenever we reflect across the y-axis, we let x equal to minus x. So just like when we are working out the x-intercept, when we work out the x-intercept, we let y equal to 0. And when we find the y-intercept, we let x equal to 0. Similarly, when we want to reflect across the y-axis, we let x equal to minus x. Okay, so we use the opposite variable. So we let x equal to minus x, so technically we have y equals minus 2 to the minus x. That's it. Okay, that's the equation that reflects y equals negative 2 to the x across the y-axis. Question 3, we're going to write the equation that rotates y equals root x 180 degrees about the origin. And so whenever we rotate about the origin, we need to let x equal to negative x and y equal to negative y. So all we're going to do is replace y with negative y and x with negative x. Or we can write y is equal to negative root negative x. Okay, you might be thinking, we can't square a negative number. That's right. But if x was negative, say for example x was negative 5, then y would equal to negative 5, which is positive 5, and that's possible. Okay, so we're just going to leave it as negative x. Okay, now let's have a look at today's lesson of odd and even functions. So by the end of this lesson, you'll be able to determine if a relation or function is even, odd, or neither. So a function is even if it has a line of symmetry in the y-axis, so it reflects across the y-axis. Here are two examples. We have a look at this. Here's our y-axis. It's a mirror image, therefore it's even. Here's our y-axis. It's a reflection across the y-axis, therefore that graph is even. Okay, so if, for example, right, we had something like this, and let's just copy the second example, but we will move it across one. So if it looks something like this, that is not even because it does not reflect across the y-axis. It needs to reflect across the y-axis. Okay. So algebraically, what does this look like? A function f of x is even if f of x is equal to f of negative x for all x in the domain. More generally, a relation is even if its equation is unchanged when x is replaced by minus x. So what that means is, if we were to replace x with minus x and expand it out and everything, we'll actually get the same equation as what f of x is. And so technically, the graph will look exactly the same. So what does that look like? Here's a few examples. F of x is equal to x squared plus 7, Well, what we're going to do is, we're going to work out what f of negative x is, which means we're going to replace all x's with negative x. So I'm going to replace this x here with negative x, can square that, plus 7. And negative x in brackets squared is minus x times minus x, which is positive x squared. And hey, look at that. That is exactly the same as this. So we have f of negative x is actually equal to f of x. They're the same thing. So they will plot the same graph. Question B. Here we have f of x is equal to negative 2x squared minus 5. So if we were to do f of negative x, what does that look like? Well, we're going to replace all x's with negative x. Negative x squared is negative x times negative x, which is positive x squared. So technically we've got minus 2 positive x squared minus 5, which is exactly the same thing as what f of x is. Pause the video, have a go with question C yourselves, and when you're ready to check it out, so continue playing the video. Okay, so f of negative x, we're going to replace all x's with negative x. Well, anything that's negative, that's raised to an even power, will become positive, right? So this will stay positive. And this will also stay positive. Negative x to the power 2 is just x squared. And that's exactly the same as the original question. So we can see here that each of these are even. Because f of x is equal to f of negative x. However, a function is odd if its graph has point symmetry in the origin. So here is the origin. If we can rotate this graph 180 degrees and it looks exactly the same, then the function is odd. So here's our origin. If we were to rotate this graph 180 degrees, this bit here will look like this, and this bit here will look like this, which means it will look exactly the same. And therefore, this function is odd. So, what does this look like algebraically? Algebraically, a function f of x is odd if f of negative x is equal to negative f of x for all x in the domain. More generally, a relation is odd if its equation is unchanged when x is replaced by minus x and y is replaced by minus y. So let's have a look at some examples. Here we have f of x is equal to x cubed. Well, what is f of negative x? Okay, so you will notice before we worked out what f of negative x is, I just want you to keep doing the same thing. What is f of negative x? So we're just going to replace x with negative x. And because a negative is raised to an odd power, the answer it will give will be negative. So that's equal to negative x cubed. Well, hey, if f of x is equal to x cubed, then technically this is equal to negative f of x, right? So here, f of negative x is equal to negative f of x, and therefore this function is odd. I'm going to do one more with you. We're going to find f of negative x. So I'm going to replace all x's with negative x. Negative raised to an odd power is still negative. We'll give a negative answer. Minus 4 times minus x is positive 4x. And now we can see, hey, let's factorize out a negative. If we factorize out a negative, we'll have x cubed minus 4x. Okay, because negative times negative will give us a positive. Hey, that looks familiar. That's that. And because that is f of x, this is equal to negative f of x. So we can see here f of negative x is equal to negative f of x, therefore it's odd. In question C, pause the video, have a go yourselves, and then you can continue playing the video. Okay, so question C, f of negative x. We have negative x to the power of 5 becomes negative x to the power of 5, but minus 2 times minus x to the power of 5 is positive 2 x to the power of 5. And here we've got minus x cubed, which is just minus x cubed. So plus minus x cubed is just minus x cubed. And hey, what if we were to factorize out a negative? We'll get 2x to the power, we'll get negative 2x to the power of 5, because negative times negative is positive. We need to put a plus sign, because negative times positive is negative. And we'll be like, hey, that looks familiar. That's that. Right? If that is f of x, then this has to be negative f of x. Therefore, this function is odd. So, in summary, if f of x is equal to f of negative x, the function is even. If f of negative x is equal to negative f of x, the function is odd. Otherwise, the function is neither even or odd. Okay? So, let's have a look at some graphs. Determine whether each graph below is even, odd, or neither. I'm going to get you to pause the video, have a go with questions A, B, C, and D yourselves. And when you're ready to check your answer, continue playing the video. Okay, well, question A. This is our y-axis, and it's a mirror image, it's a reflection. Therefore, it is even, because even functions are reflections across the y-axis. What about question B? Well, here's the y-axis. It's not a reflection, so it's not even. The origin is down here. If I were to rotate this 180 degrees about this origin, would I get exactly the same graph? No, I won't. It's going to be down here somewhere, right? Therefore, it's neither even nor odd. What about question C? Here's our origin. If I were to draw the y-axis, is that a reflection across the y-axis? No, it's not. Okay, it's not split in half. It's not a mirror image, so it's not even. But with my origin, if I were to rotate this 180 degrees, would it look exactly the same? Well, this bit here would come up here. This bit here would come down here. So, it is odd. Because when we rotate it 180 degrees, it is exactly the same. What about question D? We can tell it's definitely not a reflection, so it's not even. With our origin, if we were to rotate this section here, it's going to come something like this. And if we were to rotate this part here, is going to come up like that, which it doesn't look exactly the same. Therefore, it's neither even nor odd. Okay. What about algebraically? Use algebraic techniques to determine whether each relation is even, odd, or neither. Pause the video, have a go with this one yourselves. Okay, so always find f of negative x, see what that is equal to. Well, I'm going to replace all x's with negative x. This expands to just x squared minus 3. Hey, that's exactly the same as f of x. Therefore, it's even. What about b? G of negative x. I'm going to replace all x's with negative x. Well, here we've got negative x squared plus 3x. If I were to factor, so that's not the same as this, so it's not even. Okay, so I'll just say here, therefore not even. Let's factorize out a negative. If we factorize out a negative, we've got x squared minus 3x. Well, they're not the same. This is x squared minus 3x. This is minus x squared minus 3x. So don't forget about that minus sign. Therefore, it's not odd, because it's not negative f of x. Therefore, this is neither. Okay. Question C. So f of x is equal to negative x cubed. So let's find f of negative x. Well, negative x cubed is negative x cubed. Therefore, we got negative x cubed is positive x cubed, which is not equal to this. This says negative x cubed. This says it's x cubed. So I'm going to say, therefore, not even. So because it's not even, let's try and see if it's odd. I'm going to factorize out a negative. If I were to factorize out a negative, I'll be left with negative x cubed in the brackets, because negative times negative is positive. And hey, that looks familiar. That looks just like this, which is f of x. So f of negative x is equal to negative f of x. Okay, it's equal to negative f of x. Therefore, it's odd. Alright, last one. We're going to just replace all x's with negative x. Well, that all stays the same. And this minus x to the power 2 is still just x squared, which is the same as f of x, or y. Therefore, this function is even. Okay, so have a go with exercise 4C, questions 1 to 6. If you want to extend yourself, have a go with question 10. That's on page 133 of the textbook, and it's due on Wednesday next week. And that's it for this video.